Do you guys want to start with some questions on some stuff?
Yes.
Sure, let's do it. Question it up. I use that on occasion. Blake?
Can you do number 24? Or can you specifically draw it?
Sure. So I can't screen cap this for whatever reason. The page that I would be using to screen cap it is says I can't read it, so I'm just gonna have to read this. It's okay. It's not your fault. It says a trough is 10 feet long, and its ends have the shape of isosceles triangles that are 3 foot across at the top and have a height of 1 foot. Okay, so it's like, here's my trough. And it's like going back into 3 dimensions here or whatever.
Oh.
I guess that one is one of those. Okay.
So that's how you're supposed to draw it?
Yeah. If the trough is being filled with water, so here's my water tap. At a rate of 12 cubic feet per minute, how fast is the water level rising when the water is 6 inches deep? So there's some water in there, whatever. All right, so the shape of the water in there is a triangular prism. So my volume is going to be the area of the base times the height, which in this case we're told it's 10 foot long. That height is going to be constant regardless of how deep that water gets, right? So, but the area of the base, the shape of that isosceles triangle, is going to be different at every hot water height. So remember, to calculate the area of a triangle, it's going to be 1/2 base times height. Maybe I should say tank, and we'll call this triangle. Everybody's okay there? Now, the base and the height of the triangle, that's one way of doing it. What's another way we could calculate this, though?
Wouldn't base just be
You remember this area formula for a triangle, 1/2 AB sine C? I guess that's not super helpful for me, right? It's isosceles, not equilateral. Yeah. Okay. But you could find it, sure. Just trying to think if there's a clever way of doing this. Because both of these two things, the base of the triangle and the height of the triangle, are variables, right? Those are both changing with the height of the water. And we don't know the rate at which they're changing. And this is not given to us in the problem. We're looking for the height of that triangle, dt. That's what we're looking for. So let's think about what we have here, right? Okay. So this is, we're told, they're 3 feet across the top. I assume that's what they mean. Since this is an isosceles triangle, I know that those are going to be half, right? And we're told this is 1 foot. And if I say do this, that is a similar triangle to the isosceles one, right? So if I call this like B2 and H2, I know like B2 over H2 has to equal 3 over 1. The base of the tank, or the base of the, for the trough, and the height for the triangle on the trough. Everybody's okay with that? So I know that base is going to be 3 times, thank you. Jillian, it's for you. Is going to be 3 times that height. Everybody's okay there? So I can say then my area is 1/2 3 times H times 10. You guys all buy that? So now I'm ready to differentiate. Oops, that's, yeah, it's okay. So if I fill this in then, okay, one thing, this wasn't supposed to be there because it just, that was an area formula. So my volume then is 1/2 3h squared and then times 10. So dV dt is going to equal 1/2, well, 3/2, and then 2h dh dt times 10. And my volume is changing at 12 feet per second. The height is at 6 inches, so everything else was in feet. So I'm going to call that 0.5 foot. Everybody's okay with that? So it should be 12 over 15 should equal my dH dt. And this was an even one, right? Let's double check her. And again, this would be like feet per whatever's minute or something. Yeah. That's right, you said? Oh, good. I'm just going to double check because I'm a maniac like that. I gotta know! Yeah, 4/5. Good. Jack?
For number 17, I think I might have read something wrong or drawn something wrong because it's just not
Yeah, this one I thought was one of the more tricky, was one of the trickier ones that I picked. And this one I can screen cap. I think it's on the other page. Yep. Just because the picture is kind of tough to get correct. It says a man starts walking north at 4 feet per second from a point P. Okay, well, here's P. I'm going that way, right? 5 minutes later, a woman starts walking south at 5 feet per second from a point 500 feet due east of P. Okay, so she's going to be going that way. Now, the 5 minutes later, that means that the man's got like a head start on it, right? So how far can you walk at 4 feet per second in 5 minutes? 4 times 5 times 60, right? I think that's 1,200. And then from there, we're changing at 4 feet per second, and she's changing at 5 feet per second. And we know they're 500 feet. That length is constant, right? That's not going to change, the distance between, well, the P and the Q in this case. And then it asks how far or at what rate are they moving apart? So that's going to be like that distance. Everybody's okay with that? After 15 minutes from when the woman started walking. So like this would be like t equals 20 minutes since the man started walking at time 0. And then 5 minutes later at time 5 minutes, the woman started walking. And then 15 minutes after that is we're going to start measuring how far they are apart, or the rate in which they're moving apart.
After the woman starts walking.
She started walking at time 0. Oh yeah, yes. She started walking at time 5. And then 15 minutes after that, we're now at time 20. Right? Everybody's cool? So if I take a look at this, what kind of shape does this most closely resemble? Yeah, a right triangle, in fact, right? So the way we're going to think about that is whatever that woman is doing, we're just going to stick on over there. That's still 500. That's going down by 5 feet per second. Does that feel okay to everybody? Okay. Now, this side, let's call it y, that's constant. Stays 500 feet per second. Everybody agree? This whole side we're going to call x. That's changing, though, at each second, correct? What is the dx dt for that side? 9, right? At time 5, that side is 1,200. 1 second after that, that side is going to be 1209 because you got 4 longer on one end and 5 longer on the other end. Everybody agree? And that's positive change because it's getting bigger, right? And we want dz dt when t is equal to 20 minutes. That's what we're asking for. I'll call this side z. Sorry. So far, so good? All right. So, Pythagorean theorem, oops. So that's going to be 2x dx dt plus 0 equals 2z dz dt. So there's my derivative. So I have to figure out the value for x. So at 20 minutes, what is the value for x? 1,200 plus 9 times 15 times 60, right? So that's 9,300 feet. Everybody's okay there? And we also need a value for z. So z is going to be just found using a Pythagorean theorem, right? Because now that we know how long x is, and we know how long y is, this is just going to be so we're going to have that dz dt is going to equal 2 times 9300 times 9, that's the dx dt, divided by 2 times the square root of 9300 squared plus 500 squared. And that should be our answer. Assuming that I remember all that mental math correctly. Is that okay, everybody? I think this answer is supposed to be just a shade under 9, right? Uh-oh. Oh, I forgot the 2 in there. Thank you, John. Yeah, actually, let's just do that. There we go. So about 899, which is, I think, right on, dead on to where we're supposed to be at. It looks so easy when Mr. Kulik does it. I stumbled through this one a little bit, 5th hour. They asked about it also. I got it on the first try, but I stumbled around a little bit more than I did with you guys and like trying to figure out how the best way to do this. Yeah. Well, and the temptation, I mean, it's very tempting to think about this as 2 right triangles and try to add on the DZs. The problem is then this side, the y side, becomes variable also, because we don't know that the rate in which that's going to be changing, because as those 2 get further apart, it's going to be sliding further to the left as that other side's going to get longer. You know what I mean? Or the downside's going to get longer than the upside, or at a faster rate anyways. So it's like you just had to kind of, the tricky part was realizing that you can just combine those 2 rates into one for that side. So it's a sneaky one. I know. Luke?
Taking a look at 26.
26, sure. This is on the page where I can't screen cap it on there. So it says a swimming pool is 20 feet long, or 20 feet wide, 40 feet long, and 3 feet deep at the shallow end, 9 feet deep at the deepest point. A cross section is shown in the figure. If the pool is being filled at a rate of 0.8 feet per minute, how fast is the water level rising when the depth at the deepest point is 5 feet? Okay. Boy, that is an annoying to draw picture there. All right. So the type of equation I definitely need is a volume equation, right? What type of shape is the pool going to form? It's a prism, right? So area of the base times the height, or in this case, it's going to be the 20, the length, or the width of the pool, excuse me. I can tell that because when I look at the cross-sectional area they give me, if I add up the width of that cross-section, 6 plus 12 plus 16 plus 6 is 40. So I know that that's the one dimension. So that part is a constant. What I'm going to have to do is figure out the area for this base. How am I going to do that? Well, I see a triangle plus a rectangle plus another triangle. You guys agree with that? When you look at the cross section, I didn't want to draw it. It's like, or there's a little flat, I guess, there. Oh. Like that or something. So I see like, okay, I have a triangle. Oops. I have like a triangle here. I have a rectangle here, and I have another triangle there, or whatever, right? So 1/2. Now this distance, I'll call B1. This distance I'll call B2. I'll call this one B3. And I'll call this distance, that's going to be changing. I'll just call that H for height. Everybody cool with that? Or maybe I could call it D for depth. I don't know, whatever you want to call it. I don't think it was, I think I meant to put 20 there. My apologies.
And the 20 is because of the width.
Yeah, yeah, because this is the 40 side here. And the depth is definitely not what we're looking at in the cross section, right?
Yeah.
So this is just like going back into like 3 dimensions, right? The nice part about this B1, B2, B3, those are constants, right? I can just read those from the cross section. This piece was 6, that's 12, that's 16, and this piece over here that doesn't matter is 6. Now, how can I tell that piece at the end doesn't matter? Yeah, it says the water's depth is going to be 5 feet. We're told that that much is 6, so it's never going to get up to that little shallow end part. So I don't have to worry about it, which is cool. So my volume is going to be 3H plus 12H, that's 15H, plus 8H, that's 23H. So I think dV dt then should be, that's 4600 dH dt.
How do you get 460? Is that just multiplying 23?
23 times 20. I don't like this already where they're going. So that's 0.8 feet per minute equals 460. So I guess the dH dt should be 0.8 divided by 460. I'm a little suspicious of what I've done here because what am I missing? And have to plug that 0.5 in anywhere, did I? Yeah, that's not the right answer.
What 0.5?
Ah, yeah, of course, Mr. Kulik. Okay. Yep. Sorry. All that stuff is wrong. I mean, it's the right idea, but it's wrong. Yep. What did Mr. Kulik not do? That height there is not guaranteed to be 6. Or that width is not guaranteed to be 6, right? Depending on where that width is, that's going to be changing. Everybody's okay with that? So what am I going to do? Similar triangles, right? So I can say B1 over H is going to equal 6, and then the height there is 6. So there I can just say B1 is equal to H. So this would be 1/2 H squared there. And the next one I can say B2 over H is going to equal 12 over 6. So there B2 is going to equal 2H. So I have 2H squared. And in the third spot, I'm going to say B3 over H is going to equal 16 over 6, which is 8/3. So B3 is equal to 8/3 H. So that's going to give me, when I do the 1/2, I'll get 4/3 H squared. And when I add that stuff all together, what do I have here? That's 3/6 plus 12/6 plus 8/6. So that should be 23/6 H squared. Oh. Oh. Here's the good news, though, guys. Here's the good news, guys. So here, the base would be a different length. But what about here? That's constant. That's constant, right? So we don't even need this piece. That piece in there is just going to be 12 times H. Okay.
Mr. Cook,
Yeah.
I just wanted to say that this class got extended till 11:50.
Oh. Would have been nice for them to like make an announcement and not just like send out a stupid text or whatever.
Miss Anderson just emailed this.
All right. So we go to 11:50, huh? Okay. Fair enough. All right. So where's my picture again? All right. So we have that, right? Okay. So let's do this again. So again, this is 3/6. This is, oh boy, is he 72/6. And then this one will be 8/6. So that should be 83/6. Oh. Fair, excellent point. Excellent point. All right. So 1/2. That's 3/6. That's 8/6. So that's 11/6. I know. Just grind it out. All right. So I get here, that's 8/6 plus 3/6 should be 11/6. H squared plus 12h. So that's my base. So my volume then should be that, and we distribute things through, so that's 220/3 h squared plus 40, sixths, right? Yeah, thank you. So that's, just make that 110/3 then, plus 2400h. Okay. dV dt is equal to, I like this better now, right? 220/3h plus 24 or 240 dH dt.
Pardon this interruption, Notre Dame Prep teachers and students. Teachers and students, if you have not checked your email, please do so in order to see the updated schedule to accommodate the long mass today. This period will run until 11:50. If you are assigned to first or second lunch on B days, you go to first or second lunch according to the new schedule that has been updated. For those of you with third lunch, you have a new assignment. Mr. Osecki, Ms. Pakala, Mr. Palega, Mr. Schneider, and Ms. Zimmerman's classes will go to the first lunch, and to the second lunch will be Ms. Garcia, Ms. Hall, Ms. Kroll, Ms. McGinnis, and Ms. Moody. Again, if you have any questions, please check your email.
Why isn't there a DHDT after the 220?
Shoot, there should be. You're absolutely right. Dang it, Mr. Kulik. I just got excited, you know? Yup.
Although that doesn't really change much.
Oh, it sure as heck does, because now we have to factor that out and divide, right? So now DHDT is going to equal 0.8 divided by 220/3 times 5 plus 240. That makes more sense. The other one, I'm like, I'm going to get a negative number. What is wrong with this? Come on. Yeah, that's what we're looking for. Just a pain in the tuchus. But that's okay.
Didn't we get that?
Yeah, that's the right answer.
No, but like, didn't we just get, like, we just got that doing it the other way.
No, I don't think it was that. I think it was that.
Oh,
It was close.
pretty close, yeah.
It's close enough that you might have been like, oh, that's probably right, just rounding. No. Mr. Kulik knows better. I'm like, that ain't right. And I, again, remember when we did it this way, how did I know something was up? I never had to plug in the 5, right? With the depth of 5. I never had to, I had any place to plug that in. I was like, well, that doesn't seem like I did that the right way. It's like, oh yeah, that's because that was a toughie. A little bit of geometry there. All right. So again, we had originally planned, I told you guys that we were going to try to do like a homework quiz today. We're not going to do that today in class. What I'm going to ask you guys to do instead, so I found, I should say, I didn't make them. 6 of these related rate questions on the AP site. My God, I did this already. And they're called related rates. Now, you're not going to answer them in here because these are all former free response questions or versions or parts of a free response question. And to do the free response on here, you just like type in your work in here, and the school is going to have to grade it anyways, which just feels like a bigger hassle than if you just write on a sheet of paper and hand it to me. So we're going to do these 6. You can work together. Doesn't matter how many people. You can take as much time as you need. Doesn't have to be done today or tomorrow or the day after. At some point, you can ask me if things are right. I'll tell you if it's right or not. I won't tell you what's wrong with it the first time, but I'll tell you, yes, that's correct, or like, nope. Probably after two nopes, I'll help you look for something, at least the first obvious thing I see that's wrong. And we'll count that as the quiz grade. Everybody feel cool? Yeah. You do have to turn your own thing in. So like, even if you're working with someone, you should have your own set of like work and answer.
Do you want it handwritten or?
Handwritten's fine, to be honest with you. It's probably easier for everybody to just like take it along and handwrite stuff. Particularly if you have to look at the question on the tablet, that's kind of a hassle to, I guess you could screen cap it or whatever, but like whatever's easier. I don't really care how you give it to me. You know what I mean? Everybody feel like that's fair?
Yes. Yes.
When does it close by?
Mm.
Oh, the deadline for this?
Oh, so you're not turning anything in through the AP site, so it doesn't matter. It still should be viewable. Yes, you may.
Oh,
We're-
so like by next class.
I think that's ridiculous. You'll take more time than that. When you're done.
Oh, just wait. Oh, okay. Oh,
When you're done.
okay.
Like, not like a month from now is ridiculous. Like, that's not, but like,
Sure.
you know, we'll give you guys a minute, or should probably be able to get a little bit more time next class to touch base. Probably again the class after that to touch base. And then, you know, I would say before the test date, whatever the test date is, even if it's bringing it to me, handing it to me on the test date, I guess that's fine. Because at least you've gotten some feedback on it. You probably have talked to me. I've been like, yup or nope, for at least, you know, several of them. You know what I mean?
Yes.
That feel fair to you guys? So again, some of these are quite challenging. Some of them are not bad. Don't feel like you need to, if you're like, I don't know what to do with this, then skip that one and come back to it later. You know what I mean? Find somebody or some buddies, work together, talk it through. These are very much like, you know, like you get some intuition by reading the question, thinking about it, and talking about it with somebody else. Like talking helps. I insist that no one work alone. You must talk to another person about it. Okay? So nobody sit there silently like doing their own work. Pull your desk up next to somebody, like talk to another person, read it through together, draw a picture together, agree that the picture's right, start filling things
I'm
in.
gonna do like since we do have 10 minutes, can I do some self-reflection?
Yeah, I guess. But
Just for
don't
the
be
10
selfish.
minutes. You know.
Don't be selfish about your reflection
No
though.
girl boss.
These aren't safe.
Does everybody feel this is okay?
Yeah.
Nobody's upset by this? This feels like probably the better way of getting some practice on this is just like do some, and I'll just keep telling you right or wrong, and you'll keep going back and trying, and then you'll be able to figure it out.